So the first of those is Will. Will, you're one of the first users of Dart internally, right?
My team was, yes.
Yes. To talk about how he uses Dart and Angular and Flutter inside Google to build real things.
This is synergy.
Synergy.
Servus, vielen Dank. Ich bin froh, hier zu sein. Any Germans in the audience? One. Oh, okay, three. Okay, all right. Thanks for hosting us. I'm going to talk about one of the largest and earliest applications we've had built in Dart at Google. We don't really talk a lot about it because it's an internal application. You wouldn't be able to see it unless you work at Google. It's the system that we use to power sales. My name is Will Ekiel. I'm an engineering manager, and I manage the team that builds the UI for mobile and for web. Any other managers in the audience? Any managers? One, two? Oh, yeah. Okay. I'm going to tell you about a little bit about the perspective of managing a project built on Dart and some of the things that might be interesting to your manager. I don't know. Okay, so let me tell you a little bit of background. So if you have a product that you need to sell, you're probably going to need salespeople. And if it's a successful product, a big company, you're going to have a very big team of salespeople, and they're going to need some software to stay organized. So Google is just like anybody else. We use a CRM system, which is called Customer Relationship Manager, and that's what keeps the sales organization running. Just bear with me very quick. The CRM system is supposed to make the salespeople smarter. It lets them see who the customers are, what they need, lets them understand what the revenue, what kind of revenue they get, where it's coming from, lets them plan jointly with the customers. So for example, if a customer needs to introduce a new video game or a new movie, our salespeople can work with them about how to do that. And then it lets them collaborate because a lot of the products are complex. You need to sell them in teams, so you need to be able to work with one another. Now, unlike other companies, Google has its own CRM system, which is the system I work on. Why would we do that? It's really important for us to have a very fast system. We have a lot of data, and we need to crunch it very, very quickly, and we want to show a lot of data in a very simplified manner very quickly to our salespeople. So it needs to be very, very fast. We like to stay on top of innovations and be in control of rolling things out as quickly as possible. We have a lot of other systems, so we would like it to be very deeply integrated with everything else that's going on. Update real quick if something changes. And the other thing is we want it to be tailored to our values and the way that we sell and our workflows, and we want to be in control of that. So give you a few numbers. This is a big application or not, I don't know, is it important? That's not a number, it's an order of magnitude. But a lot of revenue, I can't say how much, but a lot of money is managed through this system. So it's a very important system. And it's written 100% in Dart. The front end, at least. It's been in production for 3 years. It's been serving live production traffic, mission critical, 3 years ago. As of today, we have 30 engineers whose only job is to write Dart code every day. 500,000 lines of Dart code. And about 40% of that is shared with other applications, such as AdSense that you heard yesterday, AdWords, and the Angular Dart widgets that Ted talked about. What else? All the code is strong mode clean. We have 800 Angular Dart 2.0 components. Angular Dart 2.0 launched yesterday, so no, we did not write all of that in 24 hours. We've been in production, serving, again, live mission-critical production traffic for 6 months with Angular Dart 2.0. So when we launched it, we've already dog-fooded it ourselves quite a bit. All right. This is kind of what it looks like, minus the numbers, which are confidential. But I can kind of show you that it's a complex UI. There are dozens and dozens and dozens of views like this, okay? And lots of components, and all of these little panels are reusable widgets, and every single thing is an Angular component because we like it to be reusable. So there's a lot of stuff going on. And this whole thing needs to build in under 1 second. It has to make RPCs too, so minus the cost of the RPCs. So it has to be very, very performant, which is tricky. So 3.5 years ago, we had this legacy system that had reached sort of the end of its evolution, and we had an opportunity to start afresh. So we looked around at a bunch of different things, and this was before my time. I've been in this project for 2 years. There was another team that was here before. And we looked around all the other possibilities, and Dart looked very appealing. Several reasons. Dart could scale because we need to support large. We knew it was going to be a large team. We knew it was going to be a large application because the previous application was a beast. We knew that Dart was promised to be very, very productive, as we've heard here already. Productivity was really important because our build times had gotten very slow, for example. We wanted a system. We wanted a language that allows you to had good libraries to begin with, but allowed us to build a lot of libraries because we really wanted to be able to not just build one application, but build an ecosystem and leverage the investment from building one application through all the other applications, right? And you saw in the vast amount of time, of code that we are able to share. And last but not least, it had to be easy to learn because we knew that it was going to be a large team, and it had to be easy to join people to the team. Or people didn't know, nobody knew this stack, so it had to be easy to pick it up. Well, there's at least one way of finding out if all of this is actually true in practice, which is to try it out. So the team did. And their initial impression was that, yes, everything is true. And they launched an entire CRM in 6 months, starting from nothing. And thanks to Dart, 3 years ago. And that included porting AngularJS to Dart and launching Angular Dart 1.0. So yeah, it's very productive, evidently. All right. You would want to think that when you're done launching something, that's your architecture, you can just move on and stand back and all. But in reality, you need to keep evolving. You need to keep adding a lot of functionality. So in reality, you have all people sticking their hands there and trying to scale, evolve your system without toppling it, right? So that brought us to one of the problems that I don't know if you guys can relate to, which is how do you scale an application after you have an initial launch, and you need to now say, okay, now make it 10 times bigger. Okay. So I'm going to go tell you a little bit about some of the scaling problems we found with Angular, and which explains why we have Angular 2.0 today, for example. So how many of you guys have used Angular? No? A lot? Oh, yeah, okay, cool. So Angular 1.0 had this really awesome feature, which is, well, Angular in itself allows you to do data bindings declaratively, which saves you a ton of code. It's very, very productive. But we were able to do bidirectional bindings, and we used a lot of these. So, they have two things. They both sync to each other. You had a third thing. Before you know it, you end up with one of these. Obviously, not with three things. You would see it. But when you have a lot of them, especially when you're adding components that you didn't write and that not always run the same way, and they make a bunch of RPCs and so on. So this was one of the problems that we had encountered. Angular, it's actually not as bad as it might seem. Angular will run through the loop several times. Eventually, the model stabilizes. You just wasted a little bit of CPU, but you chug along. After a while, eventually, as the system keeps getting bigger and bigger, it needs to run more and more of these loops. Eventually, we were running 10 of these, and it was still not stabilizing, just giving up. So that's a problem. Then another version of this, the similar problem is with unidirectional bindings. You have these hierarchies, right? Everything components nested within all the way down. Again, not with 3 levels. We had 11 levels in our system. And before you know it, I mean, there's somebody has to propagate some state back all the way up, and that triggers another digest and change propagation. Same kind of problem. For the first kind, you solve that by getting rid of bidirectional bindings. You need to re-architect your app a little bit. This one, we came up with this event bus, which decouples it and lets you, decide when you take the changes, which is a little bit, if you guys have looked at Redux, similar kind of directionally in the pattern. The other thing that was a big deal was, how are you going to build a UI in 1 second when it takes you about 800 milliseconds to do an RPC? Well, maybe you can do it in 1 second on average. If you can do a lot of caching, you're able to build your UI out of cache data, right? So has anybody ever used Streamy, or they know about Streamy, the library? No. Yes. Well, no. People that don't work. Okay, not in my team. Okay. So this is a library that some folks in our team developed, and it's open source. You can play around with it. It's pretty smart. What it does, it intermediates all your RPCs, and if you get a cache hit, it caches all the responses, and if you get a hit, it gives you the cache data. But in the background, it still issues the RPC, and it compares it with what it just gave you. And if it's different, it gives you a newer version of the response. So what this means is that the experience of the user sees is, as they're navigating, they see data that's perhaps a little bit stale, but depending on your system, it may or may not change that often. And still, they need to understand what's going on, and then maybe in a second they see one cell get updated in the table, which is fine. Now, Streamy, given that's what gives it its name, is that it leverages Dart streams, which are pretty awesome. Everybody here's a fan of that. You don't have to write your code that with explicitly checking the cache at every single place, which would be very annoying. So you just you can do it this way, or you can just listen on the stream, and you can either get 1 value if there was a cache miss, or you can get 2 values if there was a cache hit and there was an updated value. Or we don't do this right now, but we could. The server could push you a new value at some point, and you can get additional values. So this is a very good. We were very pleased to have constructs like streams available to us. So I don't know if you saw this thing. What's this services thing on top of the UI components? As the app grew, the UI components started to accumulate more and more business logic. Some of them were making RPCs, and they had much more complicated setup, and they did too much stuff. So it became very hard to test them and to debug them. So what we did is at some point we said, okay, fine, let's do a big refactor, and we moved all the code out of the components into just pure Dart objects. And by moving all of this stuff out of the component domain and into just plain Dart domain, tons of advantages. One is you can just use all the features of the language. You can use inheritance. You can delegate certain behaviors to mixins. You can have services that manage the life cycle of multiple components, like an entire view. You can have view services that cooperate with other view services. I don't know, all sorts of stuff. So, plus all of the stuff can be tested later on in just simple command line VM tests without involving the browser. This saved a ton of time. I recommend that you look into doing things this way. Anyway, we had a very close partnership with the Angular team. They actually sit across the hallway from us. a lot of the stuff that I just showed you, plus many other things, are actually in Angular and Dart 2.0. And as you know, in the release version, you guys can just take advantage of a lot of the stuff that we had to go through. You guys don't have to. So we also, our testing team was able to take advantage of a few features of the Dart language, such as that allow you to do static analysis and generating code. And they built us a few very cool tools. They're here, by the way, Tianfei and Jingbian. I don't know if you guys write any memory leaks, but we do. They're able to find, they build tools that are able to find specific code patterns that lead to memory leaks. It's kind of cool to be able to do that. Also, there's the setup of certain test cases can be a pain to do, a lot of boilerplate, but it's not quite exactly always the same. Tools to build that. You saw Matan talk about page loader and page objects in Ted's talk. We have generators for that, and all of these tools are going to be made all open source, or they're already open source. So we also partner very closely with Dan and the Dart team. As the app started to grow and get out of hand, the refresh cycles started to get very, very slow, so we told them, and they delivered. They made it 8 times faster this summer. So if you haven't used the tools since the beginning of the summer, they're a lot faster now. All right, what else? People on the team, what do they tell us? We hire some people who are fresh out of school. This is their, one of their first languages that they learn. And they tell us that Dart feels like a smaller, more agile blank. Any guesses? I'll give you a hint. It starts with J and ends with Ava. It's very easy to learn, very easy to pick up, very intuitive for people coming fresh out of school. Now we have people who have a lot of experience at Google with different tech stacks, and they tell us this is a much more productive stack than anything else they've worked with. This is not like me with timers and taking benchmarks, but just asking people, okay, how long would it take you to implement this feature with that tech stack or this tech stack? Pretty much, I get this answer consistently. A lot faster. Okay, we're done. Everything's great. We have a productive team, productive tech stack. We have a great application, by the way. Users love it. Great partnerships. We're good. Well, there's still time left on the clock, so obviously you know that's a psych. So there's something missing. Something very big missing from all of this. Any guesses? Yes. You saw the slides. Okay, so yes. What about mobile? What about mobile? Yes, mobile. All right. I guess we missed mobile. Let's do mobile then. All right. Voila. There it is. See? I just show you the screenshots. We put them in there. A little bit black. Yes. Done. Mobile web for the win. So you just need to have very small fingers to tap on that. What happens is, even if you did, even if that made sense, there are different workflows. The kinds of things you would want to do on your phone are not the kinds of things you want to do on your desk. It's completely different things. So it's not just that the user experience needs to be designed for mobile, but just like different features or different interpretations of the features. So I don't know if that's a salesperson. I know that's a model. It's a stock photo. I don't know if salespeople on the go look like that or not. But we needed to find out. So we had to go talk to them, and we did. And we found out what they cared about when they're on mobile, blah, blah. And we built these apps with numbers in the real world. And so you have a bunch of visualizations, same thing. Well, different, analog thing, but for mobile. Now, we wanted to have, we didn't want any compromises in the user experience, right? We wanted to feel great, and we wanted our users to love it, right? So there was only one way to do that, which is you had to build native application. So we did. has all the gestures, everything 60 frames per second. It's great. But the problem is that, okay, we have a web stack. We have an Angular. We have Angular, we have Android. And, well, we have users on iOS. So, all right, we get to do it all over again. Okay. I wasn't excited about that. So it means I need to spin up a whole other team. No. So I was like, there's got to be a better way. And so I talked to the Flutter team. This was 6 months ago. And I'm like, okay, guys, like, can we try this? And like, well, we're like in pre-alpha. They're still kind of alpha. So like, okay, what if we if we put up with some bugs? And it's like, okay, sure. So we build a prototype, right? Because that's the only way to, well, that's one way to find out if things actually work. And honestly, I had some skepticism because I've worked with things that are cross-platform before, and they feel a little weird. I mean, when you're like in a virtualized thing that lands on, abstracts the OS. It's like it's not going to feel like the right thing. It's going to feel a little weird to be like, I can't really anyway control this stuff. So I don't know. You want to see what happened? Yeah. All right. Okay. So that happened. That's our prototype app. All the data is fake and so on, but get an idea of what it does. We built this prototype on Flutter. And it's kind of a clone of our Android app. What it does is, for instance, if you are a salesperson, you want to know how you're trending against your targets and so on. So this gives you some vital stats. We have the let's see. You can see how you're pacing. Companies that are like who's doing well, who's not doing so well. You can go and you can see it's the exact same thing. So we built this hierarchical table, which is a custom component that we had to build. We had built this, and this is one of the reasons why we had chosen to go native, so that we could create certain types of specific experiences we wanted to have. Note that, for instance, the back little arrow is a little bit different on each OS, and the text is left padded and it's left aligned on Android and centered in iOS. Flutter does all of that automatically for you. And look what else it does. See, I made this build. This is a build that we did right before I came. And as you can see, it's got a bug right there. And it's the exact same bug on both of them. So, I don't know. I mean, I'm excited about that. Because it means I get to test things once. I mean, if we fix it on one, it's going to be fixed in the other one. And I think that's a feature. So anyway, all right, let's go back to our fun. All right. So what was our experience working with Flutter? Mind you, we've been working with Flutter for 6 months, and it was buggy when we started and so on, but the Flutter team, like Eric was saying, they just kept building the road in front of us. And we were really productive with it. I mean, we were surprised how much progress we were making, because ideally we were just going to build some really tiny little toy thing. We're not even planning on building that much. But once we got started, we figured out it was hard to stop. It was hard to stop building the prototype because it was fun. Because you didn't really have to wait to see the results, and it was so productive. It got to be about we're guessing about 3 times more productive than working in Android alone. Okay, that's not even counting what it would have taken to build an iOS app. We had no problem coming up to speed. Everything made sense. I'm sure it helps if you have some mobile background. The widget fidelity, which was one of the things that had driven us to go native, is incredible. The team that's doing these things is very connected with the material design team. They know a lot about widgets. The way everything, the shadows, and all the tiny little details are very well taken care of. And I don't know about you, but when I see a project that makes some big, bold promise, and then they actually do that, I think that's noteworthy. It doesn't happen to me very often. So, sure, yeah. And last, there's this really interesting possibility you now have, which is you can share code with your web application. Okay. And they're not even beta, actually. They still got a ways to go. So, wow, I was impressed. So, given Flutter, this is actually the way we're thinking about building apps. And I think this is the way you all may want to think about them as well, which is you have your web application, you have your mobile application. There's going to be always a little bit of native code you need to write because they're never going to be exactly parity, right? But the interesting thing for me is this layer right here. This code is very expensive code to write. It's the code that has business logic, code that knows how to make certain types of RPCs. It took us a lot of work to write that code. It's pretty non-trivial. And when you're building another client, you typically have to start from scratch. Why? Because it's a completely different language. Maybe you can read them, and then side by side, and port your Dart to Objective-C or whatever. But that's not a fun process. So the ability of leveraging all of this investment and putting it on your mobile clients is actually huge. And I think this changes a lot of things. All right, so what am I excited about? Excited about the 1.0 launch of Flutter, which we have no ETA for, but I'm really excited about having that. Although, since I sit in the building next to Eric, we'll probably launch before that. I'm really excited about all the stuff that Farhad and Matan talked about with Angular, with faster, smaller code size. Angular has a very exciting roadmap ahead of them. And frankly, I'm very excited about the evolution of the Dart ecosystem. Of course, we need your help because, well, we need your help promoting it. We need your help growing it. We're making a lot more stuff open source now. So we're hoping that you guys can take it and make it bigger and contribute to it. It's yours. Thank you.